Welcome to the first video of the series Introduction to Dynamics. In this video, I'm going to be explaining equations and concepts that you will need to solve problems in the next video. I'm not going to be deriving anything, I'm just going to be showing you what these equations give you and what the variables mean. So, today I'm going to be talking about kinematics of rigid bodies. What a rigid body is, types of motion, rotation about a fixed axis, velocities and accelerations, and moving reference frames. I'm going to be using images and problems from the textbook in the upper right-hand corner. So, what is kinematics? Kinematics is the study of motion of an object, system of particles, or just one particle without considering the forces acting on them. So, we're just going to be analyzing the actual motion of the object. What is a rigid body? A rigid body is an object that does not change shape or deform easily. So my Apple Pencil right here is a rigid body because it doesn't change shape easily. But headphones are not a rigid body because as I move them, they change shape. A key trait of a rigid body is that if you have one point on it and you take another point, the distance between these 2 points is always the same regardless of what motion it's undergoing. But as you can see with these headphones, these 2 points, as I move them, they can get closer or further away from each other, so it's not a rigid body. Okay, types of motion. Translation. It's simply motion of an object when it's not rotating. So like this. This is a common misconception that this is not translation. This is translation of this rigid body, even though it's moving in a circle, because it's not rotating itself around an axis through itself. So that's also translation. So what is rotation about a fixed axis? So if I have a point in my rigid body and I draw an axis through it and it can rotate about that axis, that's rotation about a fixed axis. Every point on this object rotates in a circle around the origin with constant radius r. Okay, so what is planar motion? Planar motion is super awesome because it simplifies a lot of our complex equations that I'll be explaining in a minute. It gets rid of one of the cross products, so you have to do less math. So, planar motion is when you have an axis fixed to a given reference frame and your object is intersected by that axis. So if I have an axis and it goes like this, or if I have a plane and it's like right here, and I have this pencil right here and it's intersecting here, the points right here are never going to leave the plane. They're just going to move about the plane. So some important equations to consider while analyzing rotation about a fixed axis are these right here. Angular velocity, angular acceleration, tangential velocity. But we have to keep in mind that these are scalars. And if we're asked to find the velocity of a point, we can't just jump to these equations because we're going to be doing the velocity of points relative to other points. So we actually need to use cross products, and it's going to be more complex than this, but we need to know these equations first. So angular velocity is the change in theta over time. So if you draw a reference line through your object, like in this image right here, and it's rotating, how fast is your theta changing? Your angle between your reference line, and as the object rotates, it's going to get greater. Angular acceleration is the speed at which your speed is changing, the double derivative of the theta. So it's saying, is it slowing down or is it speeding up? So what is the instantaneous velocity of a point? You can take the distance from that point to the origin point around which it's rotating, so that's r, and multiply it by the angular velocity. Remember, these are scalars. If you rearrange that to solve for angular velocity and you take the derivative, you can find the angular acceleration to be acceleration of that point over the distance to the axis of rotation. So in order to find where these two vectors are pointing, angular velocity and angular acceleration, we need to use the right-hand rule. If we curl our fingers in the direction of motion, our thumb is going to be pointing in the direction of the vector. Another way to figure this out is using this rule. If you're taking the cross product of two vectors, you take the first vector and you take the second vector and you line your fingers up with them, and then your thumb is pointing in the direction of the result of the cross product. So it's either down, up, or whichever way your problem is oriented, that's where your third vector, angular velocity or angular acceleration, is going to be pointing. So as you can see in this image right here, the thumb of this person is pointing in the z direction. So that's the direction of angular acceleration and angular velocity. But as you can tell, angular velocity is the arrow that's indicating it is going to the left along the x-axis. That's because the object is rotating along the x-axis, but the angular velocity is pointing in the z direction, the actual vector of it. So now we're going to be talking about velocities and accelerations of points on a rigid body with respect to other points on a rigid body. So let's consider points A and B on this rigid body relative to a fixed origin point O. If we know where A is relative to this fixed origin point, and we know where A is relative to this other point, we can find out where B is relative to the fixed origin point. So that is, in equation form, the position of A equals the position of B plus the position of A relative to B. Then to get to this next equation that you'll need, the derivative of this equation is taken to give you the velocity of A equals the velocity of B plus the velocity of A relative to B. And then you're thinking, well, what's the velocity of A relative to B? Sometimes they'll give it to you in the problem statement, but a lot of the times they won't. So it's equal to the angular velocity of the rigid body crossed with the position vector of A relative to B. So from B to A. Then if you plug that into this equation, you'll get this equation, and this is the one that you'll need to solve a lot of problems. Then accelerations. To get to the acceleration equation, the derivative is taken of this equation, and then you get the acceleration of A equals the acceleration of B plus the acceleration of A relative to B. And then, again, the acceleration of A relative to B would be equal to the time derivative of the angular velocity crossed with the position vector of A relative to B plus the angular velocity of the rigid body crossed with the velocity of A relative to B. And then you can notice, well, the time derivative of the angular velocity is the angular acceleration. So plugging that in, we get this equation. And then this equation would be used if you have planar motion, 3D motion, it doesn't matter. It works for both of them. But if you want to simplify this equation for planar motion, it's written as this. And I'm not going to derive it, but note that this is a minus sign. It's easy to miss that. And as you can tell, you'll be doing a lot less math because there's one less cross product. Then if you take a look at these two terms right here, this one represents the acceleration that's tangential to point A, and this one represents the acceleration normal to point A. And then as scalars, they can be equated like this. Okay, so these are the key equations that you'll need. The ones that are in thicker boxes are ones that are essential for almost every problem, and then the other ones get you values that you'll need to put into those more important equations. So I'll see you in the next video where we'll be doing example problems. I think that a lot of these values and terms will make a lot more sense when we put context to them. So I'll see you guys in the next video.